Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are still on the topic number basis. In the previous video, we studied how to draw tables for a given operation in a given number base. In this video, we are going to take yet another example on drawing tables for a given operation in a given number base. Now let's look at the question that we are tackling in this video. We are being told to draw addition table for base 8 on the set 1, 3, 5, 7. Then use your table to solve I. 3 plus x is equal to 12, x plus x is equal to 6. Now, this is quite different from what we saw in the previous example. In the previous video, we were told to draw addition table for base 5. There was no set given to us. This time, we are drawing addition table for base 8, but a set has been given to us, which means that we have to use the set that has been given to us. So if the set was not given to us, the numbers we are going to use will be 0, 1, 2, 3, 4, 5, 6, 7, since it's in base 8. But this time, the set has been given to us, so we can't pick our own set. We have to use the set that the question gave to us. So in drawing the table, this will be the numbers in the table. 1, 3, 5, 7. 1, 3, 5, 7 is addition, so you bring your addition sign here. So we can see from here that the set gave us 1, 3, 5, 7, so we have to use the set. The question gave us 1, 3, 5, 7, so we have to use the set that the question gave us. If this set had not been there and the question tells us to draw addition table for base 8, then the set you will use will be 0, 1, 2, 3, 4, 5, 6, 7. But this time the question is telling us to draw the table on the set 1, 3, 5, 7. So we have to use the set that the question gave us. Don't forget that the addition is still in base 8. So we begin to do our addition. 1 plus 1 is 2. 2 in base 8 is 2. 1 plus 3 is 4. 4 in base 8 is 4. 1 plus 5 is 6. 6 in base 8 is 6. 1 plus 7 is 8. 8 in base 8 is 1 remainder, 0. 3 plus 1 is 3. 3 plus 1 is 4. 4 in base 8 is 4. 3 plus 3 is 6. 6 in base 8 is 6. 3 plus 5 is 8. 8 in base 8 is 1 remainder, 0. 3 plus 7 is 10. 10 in base 8 is 1 remainder, 2. Then we come to this side. 5 plus 1 is 5. 5 plus 1 is 6. 6 in base 8 is 6. 5 plus 3 is 8. 8 in base 8 is 1 remainder, 0. 5 plus 5 is 10. 10 in base 8 is 1 remainder, 2. 5 plus 7 is 12. 12 in base 8 is 1 remainder, 4. 7 plus 1 is 8. 8 in base 8 is 1 remainder, 0. 7 plus 3 is 10. 10 in base 8 is 1 remainder, 2. 7 plus 5 is 12. 12 in base 8 is 1 remainder, 4. Then 7 plus 7 is 14. 14 in base 8 is 1 remainder, 16, as we have it here. So we have now drawn the table. We've now drawn the table. Let's move on to solve the question that was given to us. The second question says that we should use our table to find I. 3 plus x is equal to 12. Now, whenever you are being told to use your table to find for this, what you have to do is that you have to try x for all the values that was given to you. So you have to try when x is equal to 1, when x is equal to 3, when x is equal to 5 and when x is equal to 7. You try x for all the values in the set that was given to you. So first, when x is equal to 1, we know that when x is equal to 1, this whole thing will change to 3 plus 1. From the equation says that 3 plus 1 will give us 12. So what we have to do is that we now have to find 3 plus 1 from our table and see if it is 1, 2. From our table, 3 plus 1 is 4. So you can see from here that 3 plus 1 is 4. But we know that 4 is not equal to 1, 2. So it means that x is not 1 is not the correct answer for x. So we move on to the next element in the set. The next element is 3. So you try for when x is equal to 3. When x is equal to 3, the equation will become 3 plus 3 is equal to 1, 2. So we have to check our table. What is 3 plus 3? From the table, 3 plus 3 is 6. Once again, we know that 6 is not equal to 12. So we can say 6 is not equal to 12, which means that x is not 3. So we continue. You try for when x is equal to 5. When x is equal to 5, the equation will become 3 plus 5. Since now x is 5, so 3 plus 5 is equal to 1, 2 or 12. So you check. What is 3 plus 5? From the table, 3 plus 5 is 10. So if 3 plus 5 is 10, we can say that 10 is not equal to 12. So it means that we have to try for the last set, for the last element of the set, which is 7. So when x is equal to 7, the equation becomes 3 plus 7 is equal to 1, 2. So check from your table. 3 plus 7 is actually 1, 2 or 12 as we have here. So we can say that therefore x is equal to 7, since 7 is the only one that gives that makes the equation true, because 12 is equal to 12 as we have here. I hope that is clear. Let's move on. The next one says that we should find x such that x plus x will give us 6. So once again, you try for all the numbers in the set. So we pick the first one. When x is equal to 1. When x is equal to 1, we are going to have 1 plus 1 should give us 6. From our table, 1 plus 1 is 2, not 6, which means that s is not equal to 1. You try for the next one. When x is equal to 3. When x is equal to 3, we are going to have 3 plus 3 to give us 6. Now from the table, 3 plus 3 is actually 6, which means that x is equal to 3. That's correct. But when you have one to be correct, you don't have to end there. Sometimes others may also be correct. So you have to try for all the elements in the set. We have found that x is equal to 3 is correct. It satisfies it, since 6 will give us 6. But you don't have to end there, because some of the elements in the set may also satisfy it, which means that in that case the answer will be 2. So if you find one, don't end there and assume that that is the only one. Others might also satisfy. So you have to try for all the elements in the set. So you try for the next element in the set, which is 5. So we say when x is equal to 5. When x is equal to 5, we are going to have 5 plus 5 to give us 6. From our table, 5 plus 5 is 1, 2 or 12 as we have here. So we can say that that is also not correct. So because 12 is not equal to 6. Then the last one, when x is equal to 7, we have 7 plus 7 to give us 6. Sorry, this is 6, not 16. So 7 plus 7 to give us 6. We check the table. What is 7 plus 7 will give us 16. So we can say that 16 is not equal to 6. So you see that from here, when we check the whole thing, we saw that it is only x is equal to 3 that satisfies it. So we can say that therefore x is equal to 3 for the second part. I hope that is clear. Thank you for watching this video. Pick more examples on drawing tables for a given operation in a given number base. Try your hands on these examples. Solve more. Try your hands on them. If you have any problem, interact with me on my social media handles and I'll help you to understand them. See you in the next video, which will be the last video on number basis. In that video, we are going to learn how to solve equations involving number basis. Bye bye.